Hello, and welcome to today's webcast. My name is Sarah Diehl, and I am a business intelligence and analytics consultant at Thorogood, and I'm speaking to you today remotely from Philadelphia. I'm joined by my colleague, Dunmire, who is also a business intelligence and analytics consultant at Thorogood. Feel free to get in touch with us via our contact details on the screen. So here's an agenda for today's session. We will begin with a quick intro to Thorogood and who we are, and then we'll get into the details of integrating analytics and data visualization tools, followed by some demos and some technical design possibilities. Then we will wrap up by talking through what we are currently seeing in the market and what you can do to get started. So for those of you who don't know Thorogood, we are an independent global professional services firm specializing in business intelligence and analytics strategies, solutions, and services with a key focus on our customers. We are a global company with offices in Boston, Philadelphia, London, Singapore, Bangalore, India, and Sao Paulo, Brazil. All of our consultants are recruited and trained in the same way to develop a unique mix of skills, blending business understanding in the form of industry and functional experience with a strong technical aptitude and deep understanding of analytical tools and techniques. We offer a full range of BI and analytics services, including strategy and roadmaps, requirements, design, implementation, and training and support. In terms of the technologies we work with, we are an independent consulting firm, meaning that we don't work with one specific technology, but we do, however, work and partner with many of the key players in the market in order to provide our clients with the solutions that best suit their needs. So I wanted to start today talking about the value of digital transformation during these uncertain times. So we know that our businesses are currently changing and constantly changing. So with digital transformation, that has led to many additional touch points, whether it be with customers, throughout the supply chain, or in the manufacturing process. Organizations have to make that new amount of data available to businesses, and it has to be fast and evolving rapidly. As more information becomes available, organizations have moved towards more modern data architectures that can process that information quickly. They've also looked to introduce more automation, such as machine learning and AI, which performs at processing speeds that humans just cannot do. And most recently, the global pandemic is a good illustration of the advantage that a digitally in tune firm can have. COVID-19 is expanding the need for more digital operations, and organizations are needing to respond in the moment to unprecedented events, and have that need for keeping a pulse on the market and getting results quickly is just intensified. So what does that translate into with people working from home? We have this sense of what is kind of like the new normal. So we have virtual collaboration using new tools such as Teams, Zoom, WebEx, and things like that. Adaptability and flexibility, so you need to be on the cloud to really get there. Responding to business needs and changes, so you need to be able to use DevOps or MLOps to productionize what you might be creating that is new. Data quality and availability, so you need your data to be accurate and available for your organization to really use it and derive the most value from it. And then finally here, prep, analyze, and present. So you want to be able to understand and show what the data means in order to really get the most value out of it. So that was our quick introduction. Now I'm going to talk a little bit through integrating analytics and data visualization tools. So as cloud data platforms continue to evolve and organizations are investing more and more in analytics, a common use case we see is the need to interact with analytical models from data visualization tools and build a cohesive end-to-end application. People want to be able to perform analyses and have data update in real time. To do this, you must have a successful data model and a properly built dashboard with relevant visuals. The ideal way to do this would be to have a method of storage, such as a data warehouse or data lake. From there, you can use analytical tools such as Azure ML, Amazon SageMaker, or Databricks to create a data model. You can then use that model to connect in Tableau or Power BI. This enables user interaction with the analytical models and allows for users to send inputs or parameters to an existing model and that kind of update on the fly to enable a true self-service experience. All of this paired together will allow for enhanced decision-making, easy and accessible sharing and collaboration, quick presentation insights, and socializing data science. So no one tool can really do it all. There are a variety of things that modeling tools and data visualization tools are independently very good at, and a variety of shortfalls for each. So most visualization tools such as Tableau and Power BI are really good at displaying data and creating beautiful dashboards. Their main purpose is really to visualize data and make it easily accessible and understandable to many people, and they're excellent in that area. Each does have its own modeling capabilities, but these capabilities are pretty sparse compared to proper modeling tools. Tools like Tableau and Power BI have very limited compute, not many features like in the actual modeling tool. You can also have a decrease in performance if you have too many elaborate calculations within the tools, and they can't really perform more elaborate analytics like you can with an actual analytical tool. In a similar way, analytical modeling tools can easily do all the things that visualization tools mentioned before cannot, but their downfalls are really in creating those interactive and shareable reports. Many of these tools do have basic visualization capabilities. However, the lack of the myriad of options that tools such as Tableau and Power BI bring. The reports are most times very static and limited in customization and are pretty tricky to share across an entire organization. These tools also typically require a pretty high technical aptitude, so the average consumer can't really go in and interact with the model. So we need powerful, reliable compute that offers ML and programming functionality, and we need to have a way to simply and clearly visualize insights from data science investments in order to bridge these gaps here. So luckily, you can use both of these tools together to solve for many of the gaps that each of these tools kind of has. So pairing analytic, modeling, and visualization tools together will allow you to leverage the best qualities of each and provide you with an opportunity here to productionalize analytics and share insights. You can make data science understandable for the whole organization and really make those insights that you're getting from visualization tools actionable. So combining these tools will allow for solutions to technology gaps and will also provide solutions to common problems within organizations as well. There are many different personas in an organization that will need to take advantage of the integration of data visualization and analytical models, and each will get value out of these in different ways. So first we have our data scientists. These are people who have kind of like the most technical skills and do most of the data modeling and creating reports, which will then be shared with the organization. Next, we have consumers. So this group of people is typically the largest and consists of people who are more like analyst-type roles or people who will need to get down into the lowest level of information and get answers and insights for specific use cases. These groups will typically be interacting with the reports most often, kind of like slicing and dicing the data in order to pull out information that they need. Next, here we have managers. So managers will usually not be interested in seeing that lower level of granularity like the consumers, but will be more interested in general insights and trends in particular areas. Next, we have business sponsors. So this group is a little bit higher level in nature and will be most interested in gaining insights and answers to key business questions that reports are aimed at answering. Then finally, here you have the executives. So this group is typically the smallest, but generally be more interested in key KPIs and overall trends across the broader spectrum. Things like this without a proper data visualization tool is a common problem that we're seeing a lot of organizations face. So say, for example, that an organization may have invested in a proper data platform that is providing clean and reliable data. The data scientists are spending a considerable amount of time and effort in creating multiple different reports each month that are aimed at answering specific questions for a small audience of similar personas. So they may create one specific report for consumers, a different report for managers, and so on. And as the month goes on, these static reports become somewhat outdated, and as new ad hoc requests are coming in and requests for updated data or different use cases, this becomes very burdensome and can require a lot of time and effort from the data scientists to actually deliver these reports promptly. Another common issue we've seen is an organization that might have custom-built reports in something like Tableau or Power BI in a productionized tool, but they are not using a proper data model or analytical model tool to create a reliable model. So they've spent a considerable amount of time and effort to create these reports that are ingestible and easy for multiple different audiences to access and understand, but without a proper analytical model, the information that's feeding these reports is unreliable and oftentimes not trustworthy. So the issue that we see a lot of times is that users can quickly realize this and lose trust in the accuracy of the reports, which is quite hard to build back. This causes the reports to be essentially useless and users to go back to the data scientists for ad hoc reports, which is really what the purpose of the visualization tool was aimed at resolving. So I've explained some of the business needs of combining these tools, and I'm now going to ask the operator to hand it over to my colleague Ben, who's going to explain to you how to actually combine these tools technically and show you some demos of certain tools as well.
Yeah, so like Sarah mentioned, I'm going to get into some of the kind of technical designs and show a few things on screen that bring to life some of these integrations or maybe some of the features that were kind of in visualization tools and analytical modeling tools. So first, if we think about tool selection, which probably isn't specific to data visualizations or analytical models, but in general, kind of business intelligence and analytics, there's a number of factors that go into selecting the right tool or set of tools for for an entire organization or maybe even a singular use case. So things we're thinking about: user capabilities and skills. So what do my associates know how to use? What are they familiar with? What are they comfortable with? What have they been trained in? Those sorts of things are important because that's kind of how you're going to have your fastest start and maybe take advantage of your team members. Organizational data strategy. So, are we pushing towards the cloud? Do we have a kind of citizen data scientist mantra that we're following? So what is the underlying strategy of the organization? Because you might kind of tailor your tooling to meet that kind of top-down strategy. Thinking about maturity with cloud, DevOps, MLOps, so some of those maybe more bleeding edge components, it might dictate which tools are even available or which tools aren't available, and thinking about kind of your ability to implement them and deploy them. So thinking about where you are on the maturity with some of those topics. Cost, always important, whether it's licensing or server cost or whatever else it is, thinking about costs in terms of picking a tool. Of course, the features and strengths of singular tools. So, I mean, in a lot of cases, I think these tools are very similar. They have similar objectives, but certainly have nuances in their user interfaces. Some of their nuances with how they compute and certain features they have or maybe don't have yet. So that's certainly that obviously wants to come into play as you're thinking about what are the key features, what are the key requirements we have for technology. Feeding that into tool selection is important. And then what are our existing investments? What's our data platform look like? What technology is it in? How's it working? What are some legacy systems or legacy tools that we've had for a while? It might be hard to switch. So thinking about what else is going on as a reference point. And that's always helpful to think about when we're selecting tools. And as we think about it a bit further, we want to understand, so what's the differentiator between tools? How are they evolving? And something interesting that we're seeing is really in kind of data science and data visualization tools evolving, and technology is evolving. It's probably evolving incredibly fast right now, particularly with the cloud and other things. But certainly within data science and visualization tools, we see that evolution. So how are they evolving? In one case, they're kind of converging on being able to integrate better. So each of the platforms or tools are adding features or capabilities that allow them to work very well together. So things like native connectors to analytical models in their data stores, building kind of these components into singular platforms. So we'll use Synapse Analytics, the fairly new Azure product, as an example, where they've combined Azure ML and Power BI and some other stuff into a single platform. So bringing these tools into a single user interface, a single experience. And then authentication, which might be a bit of a boring topic, but pretty important when we're thinking about how are we safely connecting to data science models and that proprietary information that we want to make sure we're handling appropriately. So we can see these tools kind of adding features and investing in themselves to integrate well together. But interestingly, we also see them kind of adding features from the other side. So, data science applications and tools adding visualization capabilities, which is an interesting dynamic. So things like having inbuilt visualization capabilities, which I'll show a couple examples in a bit. Thinking about collaboration. So data science, with a lot of tools, it was always kind of on your desktop, it's hard to share things. You might have some repositories and things like that, but with some kind of some of the editing capabilities, some of the MLOps capabilities, it's a bit easier to collaborate, which is important. And then productionization, which I just referenced, that ability to take something that's maybe an experiment or a few lines of code and put it into into use helps fill that gap, get kind of visualizations help to do of sharing and showing insights. And then on the flip side, we kind of have visualization tools adding some of that analytical or data science capability. So things like inbuilt R and Python scripts or visuals. So we can have kind of like our script visuals as an example. And then also kind of enhancing the computational and even data engineering and data prep capabilities. So a big part of data science is, of course, getting the data preparation and the data engineering right. Without a clean, well-architected data set, your data science is impossible. So it's interesting to see Power BI and Tableau thinking about what's our compute framework look like, how do we handle bigger sets of data and things like that. So, I guess the bet we have to make is, do we think that these tools independently are going to catch up? Do we think data science tools are going to pull on enough visualization capabilities that that's all we need? I think my bet's probably on the middle of kind of these tools will continue having great ways to integrate themselves and become even more fluid. But maybe it's an interesting dynamic to think about and understand, what's driving some of these big software companies of going in different directions. So talked a bit about an intro there, and I'd like to get into now some more kind of technical architectures or kind of how we're seeing firms pull together these kind of end-to-end flows. So we know we have a ton of data sources, whether it's on-prem or in the cloud, files, databases, APIs, all those sorts of things. And the common thing we're seeing now is pulling this data into some type of data lake, which is just file-based storage. And then within that data lake, there'll be some logical kind of maturities or refinements of data from kind of raw matching source to some type of kind of curated or refined levels. Might be throwing that into a data warehouse, so some of the new concepts with kind of Delta Lake and Lakehouse are kind of merging those two, I would say. But we might have some data warehousing needs which rely on relational structures and that type of technology. And then we think about our kind of data science tools sitting over here, and how are we getting data into them? We're pulling from our data lakes, our big repository, which is going to be a key player, maybe pulling from some warehouse, some relational stores, and we can also expect manual kind of upload or addition of any sorts of data, maybe experimentation or some type of mapping. So we're feeding a lot of data into our data science platforms, and then that's where we're building our models and doing our kind of experiments and defining those logics. And then we need some kind of intermediate step in order to store outputs. So outputs are probably going to be something like a flat file, a CSV, for example. So we might dump that in file-based storage, or maybe even push it into a database if that's the use case. And then our visualization tool would kind of fit on top of that. So we'd be able to report off of a flat file or a database or something similar to that. And this is I think pretty traditional, kind of what we're seeing at the moment. Kind of a lot of things that we're implementing is this type of flow for analytics, and it's pretty reliable. So some of the strengths of it is it's productionizable, I should say, and it's reliable and dependable. We know this is pretty proven out. You can put process orchestration around it. You can monitor it. You can do those sorts of things which are important for enterprise systems. We also have scalable features. So starting with the data science side, scaling up and down compute as needed, only using compute when you need it. So some of the benefits of cloud there as an example. But the ability to add more models, pull on more data, and the flexibility to, if we have access to an entire data lake, there's going to be a lot of helpful and relevant data there. Being able to pull on that at will is pretty valuable, and that's one of the pitches of a data lake in general. But what do we see some organizations struggling with and kind of pushing through? I think, and maybe not a technical challenge here, but thinking about like access or getting new resources, like access to data. You don't want people going through red tape, which takes 2 or 3 weeks to get access to a new data set, because it's going to hinder kind of creativity, hinder productivity. There are certainly lots of moving parts. So we're talking about a number of systems, and that's kind of just how things are, I think. But there are a lot of things to kind of think about and manage here and to get right. And you might have some level of maintenance. You have a lot of resources, and the kind of associated with that. And then you also need experts, and this is often where kind of Thorogood fits a role, but you kind of need experts in data engineering, experts in data science, experts in data visualization, all to kind of cohesively come together towards a common goal. And sometimes that can be a bit of a challenge for firms. So let's look at a slightly different example here. So same kind of structure, same platform. Some newer kind of features, and I referenced these a bit earlier, was Tableau and Power BI as just kind of examples of being able to connect directly to data science platforms and tools. So using some kind of Java or ODBC-based connectors, you can actually connect right to the analytics source or the machine learning output, and effectively don't need that intermediary, which we had at the last point, which was some type of data mart or file-based store. So kind of cutting out a bit of a middleman here, and I'm thinking about a kind of specific use case, which I'll talk through of where we see this being used. Some strengths here, and this is really the gist of it, is the ability to kind of rapidly look at data science outputs. So if I can, run my, iterate on my model, refine some features, and then execute code, and then almost immediately see it in a robust visualization tool, that's pretty helpful. Whether I'm validating, whether I'm refining my model, it's really that type of experimentation use case where we see this fitting in quite a bit. I mentioned removing some layers, which is helpful. Some of the challenges, though, the data science compute, so if you're kind of using this, there needs to be some computation somewhere. And it often means that the data science tool has to be turned on or kind of active and incurring costs, which we don't always want. That's often why something like file-based or data mart storage is more advantageous and more productionable. We do have some limits in security and authentication here. So as it's like a lot of new connectors, it's not fully flushed out. There's some gaps that probably need to be filled, and it sometimes requires extra software, which can require some extra effort, some extra maintenance. So why don't I do a quick example and just kind of show what this might look like. So I'll switch here to Databricks. So I'll do an example here with Databricks. You can see here I have a notebook, and this is actually a clustering notebook. It was built for a kind of COVID use case, actually looking at some clustering of CPG data. And I won't spend much time on it. Effectively, we're doing some data preparation. And you can see here, and I referenced earlier, inbuilt visualization capabilities within data science tools like Databricks. You can see here there are visualizations. There's some options around changing what the fields are, a bit around the type of chart, and some flexibility and things you can change, but really it's pretty strict. It's more so for kind of getting a quick look at things, and it's also not something you would want to share with an audience. It's not like a collaborative platform for visualizations, but you can kind of see how these tools might evolve. So really what this model is doing, or Snowflake model, is picking some features from our data set of what's best to define our clusters, and then if I kind of go later in the code, we'll define and kind of train our clusters. So we tried a number of different clustering mechanisms. K-means ended up being the most effective and maybe the simplest to implement for a demo. So effectively what we do here is we take our input features and then define a cluster or however many clusters from that. And what I really want to do is pretty quickly be able to look at this data and also look at it alongside my other dimensionality and my other attributes. So what we've done, and you can see another visual example here, of just output this into an in-memory table, an in-memory object, and then within Power BI, we can kind of immediately visualize that data. So, I could dump this into data lake storage or something like that, but I'm just connected right to the Databricks in-memory object. And you can see here I have so much more sophistication and capability with visualization. I can do filtering, visual filtering, so I can click on a cluster. I can understand which of my different manufacturers are competing there, how well they're competing. I can look kind of at deep SKU level information. And I also have more kind of flexibility in my color scheme, more readability, and just integration. So it's an interesting dynamic because I might use this methodology to kind of develop and refine my clusters where I want to see, is this cluster really making sense? I can't just apply statistics and machine learning. It has to have some business sense to it. So I think that's really where some of these data visualization tools come into play, is making sure we have that business sense in things that we're doing for data science, and also being able to share this. It's a lot easier for me to share this with you than it was like the Databricks code and kind of small visuals. So a bit of example there. Another one I'll kind of jump through, and if we kind of ignore a bit of the data platform around it, we'll often see ourselves using data science tools to kind of iterate and experiment and develop models. And there are some capabilities now in just data viz tools for kind of performing analytics. I'll show a couple of simple examples, but some things that we have seen are kind of developing modeling capabilities or building more robust kind of data sets within a data science tool. And then you might take little bits and pieces of that to inject into something like a data visualization tool where the capabilities are a bit lesser, but you might have some key specific things you can put into it. So something here, it might allow kind of more like non-data scientists to explore with data science techniques and kind of start thinking about that citizen data scientist mantra that a lot of organizations are thinking about. It also allows a single place to do analytics and data visualization. Some of the challenges, though, there's again limited compute. Our data viz tools don't have computation behind them. They're just meant for in-memory models that are reporting data. They're not meant for processing or integrating, transforming data all that much. It is tough to productionize this just because some of the limitations in technology and just with the general maintenance of it, and R or Python versions changing all the time, and it's a bit hard to manage. I would say it's more for experimentation, kind of it's theoretical exercises as opposed to production instances so far. And there's kind of often software installs that go along with this. So why don't I just demonstrate what this looks like. I have a couple examples here. The first one I've just kind of used, and this is forecasting of sales data. Actually just pulled a visualization from the Power BI or Microsoft Marketplace. So you can see it's forecasting with the RIMA methodology. And you can see here I've given it a sales data set. It's a couple years old, and I was looking to kind of forecast a couple months, a year or so. And you can see within the visual, I've kind of have a number of different settings which I can use. And this is kind of interesting. I'm not writing any code. I didn't have to write any code. I could kind of pick my features and certain things through the visual. It's of course limited. It's limited to what selections are here. There's not that much customization for it. But it's an interesting way to kind of get a foot in the door. If we look at our transformation, I had referenced some of the new features here. So if we see kind of the ability to kind of run R scripts or Python scripts, so if I have some either data engineering or data science code, I can run that within Power BI. Tableau works a bit similarly. And we can also see kind of new things coming on board of these tools. So you can see here a few AI insights which are just being added on. So it's interesting to explore them. I think they're evolving very, very rapidly. The other thing I can do here is I can add a bit of kind of parameterization. So I can switch between data sets. Here I just have a central and east. And let's say I switch to my other data sets, and it'll take 3 seconds here just to load the data, and then I'll want to refresh my visual. And you can see the actual visual can change. So I can kind of pretty quickly iterate and see different data sets, different cuts, what things look like. And the other quick example I'll show here is that kind of R visual, which I had referenced earlier. So you can see here, this is a kind of mock CPG dashboard. Looks at trade profitability. Power BI lets us put in R visuals. So you can see here I've used the core plot, so a correlation plot library, and then you can see there's a few lines of code really that define what that plot looks like. We've defined over here in the actual visual, and you can see we also have the option for a Python visual as well. We've defined our different inputs, and effectively this is not a Power BI inbuilt graphic. It is an R visual, or it could be a Python visual just by a few lines of code. So I think this is interesting. It's taking, if we have people that are experienced with R or experienced with Python, and they want to kind of inject some of that knowledge into a tool like Power BI, a tool like Tableau, there are ways to do it. And again, there are some limits in productionizing this, I would say, but it's kind of interesting, and it's something to certainly explore and see, what can we do with each of our tool sets. I'll just quickly here mention a few other kind of examples. I did mention Power BI, integrating with Azure ML and Azure Cognitive Services, which are some of the new Azure tool sets. So it's all coming together, and it'll be interesting to see, do we really want to keep them all together? Do we want to keep them separate and integrate them more traditionally? Amazon SageMaker and QuickSight, I think pretty recently have just been integrated. So you can apply Amazon's QuickSight, which is their visualization tool, with their key SageMaker ML tool. So kind of bringing those two together, and certainly other Viz tools will work with it as well. And something else we kind of thought about a bit is thinking about a custom web application where you might embed your data visualization tools and kind of effectively wrap it around a bit more of a robust application, which allows you to more intently and intentionally interact with something like Databricks, some type of machine learning service, where we can use an API, for example. So Databricks has a number of APIs which we could, more flexibly use from a custom web application, where you can do things like instigate a refresh, so force a refresh to happen, update parameters, so maybe that's features, or maybe that's changing a data set or changing a model you want to use, and then doing kind of scenario what-if analysis. So thinking about that type of bespoke solution, which is going to be a big investment, something needs to be maintained and grow over time. So thinking about, do we want it to be bespoke and custom? Do we want to rely on the inbuilt technology to evolve? So I'll quickly wrap up here with a few kind of points. So it's helpful for us to think about what's happening in the industry. So what's going on that influences technology? So a few things here over the past, I guess, couple of months that we're seeing. Synapse Analytics, so that's Azure's kind of new flagship application, just coming online pretty as we speak. But it combines storage, computation, machine learning, and Power BI into a single interface. So you can see Microsoft is taking kind of all their different tools, bringing them into one place and saying it's pretty easy to integrate, go ahead and do it. So we'll see how that works. I mentioned some of Power BI. They have a number of features, so AutoML, and then some of the integrated AI insights, which are kind of slowly coming online, and people are kind of teasing them out and figuring out where they fit, what they can do. I mentioned AWS kind of pulling together SageMaker and QuickSight, which is pretty recently. That is kind of that custom integration, or that kind of inbuilt integration, which removes some of the kind of setup and technical challenges, and just it just works. And then recently, and this was coming out of the Spark Summit just a week or two ago, Databricks buying Redash, which is a visualization tool. So it will be interesting to see what Databricks does with that. It's certainly kind of a partner we see a lot of interesting things from. So it's helpful to think about what's happening and how this might play into kind of decisions we're making. So a few key kind of ideas or questions here, which I'll build on pretty rapidly. Thinking about accelerating cloud DevOps and MLOps to kind of quickly take advantage of new tooling, doing kind of POC experiments to, maybe if you're evaluating technology, seeing what the capabilities are or aren't, what can we do, what can't we do. Thinking about strategy for productionization. So that's really where we see a lot of challenges, taking some data science models that are maybe built in RStudio on premise, and we're seeing a lot of customers build it in like an RStudio tool on someone's desktop, and then how do we actually share this? How do we productionize it? And there's that bit of a gap to get towards. So thinking about what is our strategy for doing that ahead of time, and then we can kind of follow that template or pathway. Thinking about limits and certainly restrictions, which we'll all be familiar with. I mentioned this earlier. What bet do we want to make? Do we think data science tools will bring in visualization capabilities? Do we think visualization tools will build their data science capabilities, or do we think we stick to integrating disparate tools? I probably stick to the latter as of now. Let's think about what's the right tool for the right job, and that's how we decide. And then thinking about really what's driving this is our business drivers, our use cases. What are our users interested in? Do they even need to dynamically interact with analytical models, or are they happy with just some descriptive reporting? And here I kind of referenced that kind of end-to-end analytics, productionization. I'm thinking about the strategy. So kind of pulling together tools, data, people, and process, and that kind of feeds into that strategy of all these different components. So how does the technology integrate? How do you force adoption? What's the delivery mechanism? So on and so forth. And that kind of technical implementation, your strategy feeds back into our base assumptions about our business, our people, and how things work. That wraps us up for the day. Thank you very much for tuning in, and have a great rest of your day. Thank you.